And I want to present the design principle of our circuit configuration. So this is our circuit configuration by using 4 diodes, a capacitor, and a zener diode, which converting AC voltage into positive DC voltage. First, our circuit has a standard transformer, and we has input voltage which is 215 volt and frequency which is 100 hertz, and we has primary inductance which is 5 Henry and secondary inductance which is 1 Henry. So in the full wave bridge rectifier, 4 diodes are connected to the function generator. The diode acts as a rectifier to convert AC voltage to the positive DC voltage by allowing current flow through the output load resistance in one direction. During the positive half cycle, diode D2 and diode D3 are forward biased and allow the current to pass through, whereas diode D1 and diode D4 are reverse biased. During the negative half cycle, diode D1 and diode D4 are forward biased and conduct electricity, whereas diode D2 and diode D3 are reverse biased. Hence, the arrangement of the diode ensures the current flow through the capacitor, inner diode, and output load in one direction. Since the polarity of the output voltage is the same, a positive voltage pulse will be produced in both the positive half cycle and the negative half cycle. Thus, the capacitor is used to filter the positive DC voltage. The capacitor can help in reducing the variation of the output voltage. When the voltage is supplied, the capacitor will be charged until the input voltage peaks. When the input voltage starts decreasing, the capacitor will discharge gradually and return stored energy. The capacitor will be charged again when the input voltage increases and the voltage supply is larger than the capacitor voltage. So the fluctuation in the rectified voltage can be reduced. However, there is still a small amount of fluctuation which is also known as a ripple. The zener diode acts as the voltage regulator. It works in the reverse breakdown region to maintain a constant voltage across the terminal during onset. The zener diode is arranged parallel to the load resistance, which produces the output voltage. The combination of parallel zener diode and load resistance is arranged in series with a resistor, which is used to limit the zener current to avoid the current diode from breaking when the zener current exceeds the maximum current. When the voltage across the zener diode is lower than the zener voltage, the zener works in a reverse bias region and the voltage regulation will not occur. When the Thevenin voltage across the zener diode terminal is larger than the zener voltage, the zener diode will act as a voltage regulator to maintain the voltage across the zener diode is the same as the zener voltage. So a constant DC output will be produced. So this is my presentation about design principle for our circuit. Thank you.
Assalamualaikum and hello. I will continue with circuit analysis. First of all, we have used a LT-SPICE software application to create a simulation for this project. We have made a full wave bridge rectifier as shown on the screen. We have used AC power supply with the 250 volt input voltage and 100 Hz frequency. We also use an inductor with a ratio of 5 to 1. So we use the formula of Vp over Vs equal to set Lp over Ls and get the value of Vs, which is 111.8 volt. We have also calculated the time period by using the formula 1 over F and obtained a time period equal to 0.01 second. Now, I will continue to show the waveform for each part in DC power supply, starting with the input voltage, which is the Vin, in AC voltage of 250 volt. Then, for the blue waveform, there is the voltage sequence can be seen with the voltage of 111.8 volt after going through the transformer. Then, from a secondary voltage Vs, it will go through the rectifier that is through a diode regulator and produce a pulsating DC with a peak voltage of 110.4 volt. The secondary voltage will be subtracted by 2 times the diode voltage to obtain the peak voltage of pulsating DC. Next, the pulsating voltage will become a ripple voltage after passing through the filter, that is the capacitor. We can see the output voltage peak to peak, which is a 5.52 volt. Lastly, for the DC voltage can be shown with a red waveform. The DC voltage shown as a voltage drop when passing through a resistor and a zener diode in the regulator. The DC voltage signal seen in a straight line in 33 volt. That's all from us. Thank you.